Hi, this is a video for COMP345, Advanced Programming, Advanced Program Design with C++. This is for week 4. This is slide set number 4, part 3 of 3. So in here, we're going to talk about inheritance, most particularly multiple inheritance, as well as virtual inheritance. So if we can go to the web page here. It's going to show where we are. So on week 4 here, so that's this slide set number 4, I'm going to add the video here. I have moved things around. There used to be virtual inheritance later on week 7. I decided to move it here. It makes more sense. And I also added lab 4.5 here, for which I'm going to make a video after this one and post it on the UJA as well as here. So let's go and see this slide set here. So here, this is basically going to talk about how inheritance is being done in C++, or some of the particularities of how it's done in C++. So here is the sum up of what inheritance is. Of course, I'm assuming here that you would all know that if you're taking this course. So essentially what you're doing is you're defining a data structure, you implement it as a class, and then if you want to have some kind of refinement of the concept that you have in your class, you can define it as a subclass, by which a subclass is assumed is inheriting things from the base class, and then you provide additional or supplemental data members and or functions to implement a refined concept that is refined according to what was defined in the base class. So that's basically a kind of adaptation, a way for you to define adapted concepts that are adapted from a high level concept or more general concept. Generally, what you have is general concepts which are refined using subclasses. So that basically allows you to have a more flexible way to do your designs. An extensible way also allows you to more modularly define your extensions to general concepts. That's a very useful way to design in a modular fashion. So there is, in most of object-oriented programming languages, this notion of inheritance. Not many programming languages, though, have what's called multiple inheritance, so which we will cover in this particular video and part of the slide set. There's also the notion, very often in many programming object-oriented programming languages, the notion of abstract classes. So, for example, in Java, you can declare a class as abstract, which essentially means that you cannot create an object of that kind. Then you would have to create an object of the sub-kind and instantiate it so that it's actually of the type of the superkind. You have exactly the same concept in C++, except that it doesn't use the same syntax and it doesn't function in the same way. It achieves the same goal, but does not function the same way as Java would do it. What else? Okay, terminology here very quickly. So you have the notion of a base class, which is the class that is above. You might say in the hierarchy. However, in C++, you can have multiple inheritance. So it's no longer a tree, it's rather a graph. So it's somehow wrong to say that if a class is above, it's above in a hierarchy. Hierarchy assumes that thing is the data structure essentially is a tree, whereas in C++, because you can have multiple inheritance, it can go like this, so and like this also. That means this is a graph and not a tree, hence it's wrong to say it's an inheritance hierarchy. So up in the graph, you have the base classes, and below in the graph, you have the derived classes. In C++, you can have multiple inheritance compared to in Java, you cannot have multiple inheritance. Well, you can have, a Java class can inherit from another class and then be implementing interfaces, which some might say is kind of multiple inheritance, but it's not exactly right, because an interface in Java is not a regular class. It's essentially, well, simply put, it's some kind of contract that you impose on the classes that implement this interface. It basically forces a certain class to implement a certain list of methods. Well, it's more complicated than that, but that's essentially what it is. In C++, you can literally have some classes that would inherit from many different classes. So you can have multiple inheritance. Not many object-oriented programming languages implement multiple inheritance. It's not a very popular, I might say, feature of programming language, object-oriented programming language, because it makes things more complex, especially for the implementation. Yes, it opens the door for more flexibility, but it creates many problems. There are solutions to these problems, but it complexifies the usage of the language as well as the implementation of the language. Plus, I'm not going to go into details here, but it's been proven that for any design that you implement using multiple inheritance, you could actually implement it without multiple inheritance. So it's not a necessary feature for an object-oriented programming language. So it's an unnecessary feature that's, yes, very elegant and useful, but it's not something that is necessary. So that's why it's not very, it is actually controversial to have programming languages that implements that. So you also have the notion of abstract classes. So abstract class is basically a class that you declare for which some of its member functions don't have a definition. And it's going to be assumed that all of the subclass or some of the subclasses down the line in the hierarchy or graph would actually provide their own local implementation of these methods that have not been defined at the level of the higher level abstract class. So essentially, you cannot create objects that belong to an abstract class. You would have to create an object of the subkind, and then if you want to create an object that is of the abstract superkind, then you would have to use pointers, as we will see when we talk about polymorphism. So derived class, essentially, here we talk about inheritance. So what a derived class does inherit, because there's the inheritance relationship between the base class and the subclass. So it basically inherits all the data members and all the member functions that are defined in the base class or superclass. So inheritance is also a transitive relationship. So if you have a chain, then the one that I see at the bottom would actually inherit from all the members of all the inheritance chain. There is some members that are not inherited, especially the constructors and the destructors and the assignment operator. So that's one of the things we'll discuss in this lecture here, in this video. As we saw in the previous video, these are actually called automatically in a certain sequence. So you don't have to call them yourself. Actually, when you create an object, inherently you would, the runtime system is eventually going to call a certain constructor to create this object and to allocate memory to it and to potentially assign values to the data members of this object. And then if this object has inheritance relationships, then the runtime system will call the constructors of the parts of the object, which are the parts that belong to the base classes that are inherited by the class of this object. So each of these parts would be created, eventually calling the constructors of all these parts in a certain order, as we explained in the previous video. So all this to say that these constructors, these assignment operators, and these destructors are somehow inherently called in a certain sequence by the runtime system. You can also define them yourself, in which case you would have to define in what is the construct. If you define, for example, a copy constructor for a subclass, you may have to explicitly call the copy constructor of the superclass. If you don't, then it would inherently call the default copy constructor. That's one of the things we're going to see in this lecture. So here, this is an example from the book by Savage. So this is an employee. An employee has a name, certain identification number, and a certain pay. And then has these constructors here, has getters and setters, and then a print check function, which is used as the part of the example here. Then hourly employee can be either an employee can be either an hourly employee or a salaried employee. So that's basically here an employee that's paid by the hour. So that's why they have a wage rate and number of hours in order to compute their pay. Whereas a salaried employee would be an employee that is paid a certain amount per week. So that's why this one has different data, a different data member to calculate their pay. They also have each their own definition for their constructors, and so on and so forth. And they also have a different print check function implemented. So, and then there's raises the notion of what is overriding versus overloading. So a function is overridden or overriding is when a member function is included in the derived class having exactly the same signature. So basically that means that if you have a function that is here that has exactly the same signature as another function that is here, for example, print check, as we will see, has exactly the same signature. So if you create an object of type hourly employee and you call print check, and you assign it, for example, to, you create an instance of a hourly employee and you assign it to a variable that is of type employee, then the print check that would be called would be this one here, if you would be using a polymorphism, as we will see in the next lectures. So here, because print check has exactly the same signature, print check here is said to override this function here. So override is about defining two functions across inheritance hierarchy. And then the one below is basically overriding the one that was above. So that has to do also, as we will see later and following lectures, that has much to do also with when you're using polymorphism. So then that raises the question as to what is a signature. So here basically we're saying if two functions across the hierarchy have exactly the same signature, so what is a signature? So of course the signature includes the function's name, then the sequence of types in the parameter list, including the order in which these types are placed in the list, in the parameter list, the types and the number of parameters in the parameter list. Signature does not include the return type, whether the function or the member function itself is declared as const, or whether any of the elements of the list of parameters are declared as const, or any of the members of the parameter list is declared as a reference or not. Okay, so there's a lot of restrictions as to what is part of the definition of a signature or not. So for example, in this case, we see that print check at this level has been declared as const. Whereas this one does not, has been declared as const, but still this one overrides this one because as far as the overriding rule is concerned, these have exactly the same signature because const is not counted in the definition of a signature. Okay, so that's it for overriding. And then there's the notion of overloading, which has also something to do with the notion of signature. Overloading is when you declare two functions essentially with the same name in the same scope, but they don't have the same signature. Essentially, in this case, it has to do with the parameter list. So, for example, when you declare more than one constructor in a certain class, and these constructors have different parameter lists, either empty list or different parameter lists for your different constructors that you may want to have, and we say the constructor is being overloaded. So basically, you're creating different versions of constructors, okay? So in the example, the constructors are overloaded, whereas the print check function is overridden. Why? Because the constructors have different parameter lists, and the print check function has exactly the same the same signature as the one that is above and below. So here it brings us to talk about the main topic here, which is constructors and destructors. So the base class constructors are not inherited in a derived class. So the thing is that the constructors would be called automatically by the runtime system, as we saw in the previous video. So when you call a constructor for the subclass, well, when you want to create an object of a subclass, then the constructors, if the class is inheriting from other classes, then it basically composed of different parts. Then eventually these parts have to be created, and then the constructor call on each of the different parts, which are essentially going to put some values inside of the members of each of the different parts. And this is all happening in a certain order as we saw before. If you have classes that implement constructors that are explicitly defined, they can explicitly call the appropriate base class constructor. If you rely solely on your default constructor, then it would behave in a default way, and what a default way is to call the superclass or the base class default constructors. If you are implementing constructors by yourself, which include some parameters that are past parameters, these will not be called automatically. You have to explicitly call them. The way to explicitly call your specific constructor can only be done in the initialization list. In Java, you can explicitly call the superclass constructor by using the super keyword. There's no such thing as the super keyword in C++. If you want to call the superclass constructor or the base class constructors, then you have to use it to call them in the initialization list. We saw some examples of that later. I'm going to show another one here. One of the very important concepts of how you should organize your constructors is essentially when you implement your constructors for a certain class, even though the objects of this class are inheriting data members from a superclass, they should actually be taken care of their only the initialization of the members that are local to this class. If this class is inheriting from another class and inheriting data members from another class, you should let the constructor of this base class to take care of the local members declared inside of this class. So that each constructor, when you design them, everybody, takes for granted that the members of a certain class, the local members of a certain class, are dealt with locally by their own constructors. Okay, that you don't have to. You could have a certain constructor that would initialize the value of a superclass member. You could do that, but that leads to a lot of confusion. Also, that leads to, if you are creating other classes as siblings of this class, it might confuse who's responsible for what. So as a rule, when it's possible, when you define a constructor, you should have this constructor only deal with the local data members of this class and not let it deal with members that it inherits from a base class. So let's go into another example here. So we have here, that's the same employee class I shown before. There's employee, hourly employee, and salaried employee. Now, employee has a name, an SSN, and net pay. Hourly employee has wage rate, hours, and salary. So here it shows only for employee and hourly employee. So you see here that the constructor for employee, what it should do is to take care of its initialization of the name, the SSN, and net pay. So that's exactly what it's doing here. So here you have the initialized in the initialization list, the name data member is initialized to the string no name yet, SSN is initialized to no number yet, and net pay is initialized to the value 0. So that's basically providing some default values when you call the default constructor. Okay. You could actually have decided not to have the initialization list and put these initializations here in the constructor. However, it's important to understand that these here, if you put them if you put things in the initialization list, it actually takes effect before the actual constructor method, because it's kind of a method, is actually being called. Also, the order in which you put the things inside of the elements inside of the initialization list is not important. So the order in which these would be initialized is the order in which they are actually stated in the employee class. Even if you put net pay here before name, it is going to be initialized in the order that they appear in the class. Then here I can actually overload my employee constructor by having a constructor that takes 2 strings. For example, that receives a string name that is going to be used to initialize the name data member. And it may also receive a string number that is going to be initialized to that's going to be used to initialize the SSN data member. And then still net pay would be initialized to 0. So you see here that I can have parameters to my constructor, which are then passed as values to these members of the initialization list to initialize the values of the object, of the data members of the object. Then, so that's how you can do it for the superclass or the base class. Now, what happens for your subclasses? Of course, here the additional thing that happens is that when you create an object of the subkind here, then the members of the base class need to be initialized. So how do you do that? So here is the constructor for hourly employee. So you see that in my initialization list here, I'm actually calling the constructor of the superclass. So you can have a call, if you want to call it this way, you can have a call to a superclass constructor inside of the initialization list. Okay. And then it would actually continue in the list. So basically here, when you create an object of hourly employee, of type hourly employee using the default constructor, it's going to first call the constructor of employee, which is then going to assign these values to these data members, and then we'll continue here and assign 0 and 0 to hours. The thing is that if you don't put a call, explicit call to one of the constructors of the superclass, even if you would not put that here, the default behavior would be to call the default constructor. So in this particular case, whether you put that here or not, it would call the default constructor. So if you don't call any default constructor in if you don't call any constructor in the initialization list, it is going to call the default constructor of the base classes. Another thing here. So you see that here, I want to call in this overloaded constructor I have for hourly employee, I want to call this particular constructor for my base class. So if I want to do this, then I have to put the call to this constructor, this specific constructor inside of my initialization list. If I would not put it here, then it would call the default constructor, which is not what I want. So if I want to specifically say which constructor is to be called for my base classes, I have to explicitly put it inside of my initialization list. Okay, let's go forward. So again, recapitulate, the assignment operators and copy constructors are not inherited. Exactly the same thing as the other kinds of constructors. So assignment operator is actually the operator that is called when you use the assignment operation between objects. Okay, if you have a certain type A, let's say an employee, and you assign it to another object of type employee, it will call the assignment operator of the employee class. The particularity is that there's a lot of resemblance, if you want, in conceptually speaking, between the assignment operator and the copy constructor. If you want to, when you assign an object to another object, you're essentially making a copy of this object and then assigning it to the other object, such as is the copy constructor also, which is creating a copy of an object. So there's a lot of, resemblance, conceptually speaking, between assignment operator and copy constructor. So the thing is that, well, for a copy constructor, as we saw, when you create a constructor, if you are creating an object which has base classes, the copy constructor would have to call the copy constructors of the parts of this object or the base classes of this object. Same thing would go for the assignment operator. If you assign an object to another and this class has base classes, then the assignment operator, when you call it on this kind, should actually make a copy of all the parts that are inherited as base classes of this particular class, of the class of this particular object. So when object is assigned, the compiler implicitly uses the copy constructor to make a copy of the object. Then we'll use the assignment operator to assign the object. We'll show some exceptions to this rule in the following slide. If the class is derived from a base class, these operations are called on the base classes themselves, which is very similarly in actually the same order as the different constructors are being called when you have different parts that are the parts of the base classes of a certain class, as we explained earlier. So there's a lot of similarities between what I explained about in what order the constructors are being called and the assignment operator and of course the copy constructor. Particularity here is that if you use the default constructors or copy constructor and assignment operator, there is a default version of them that is created, much like when you create a class. If you don't define any constructor, there's going to be a default constructor, default parameter-less constructor that's going to be created and used by the compiler. Now, if you use these default assignment operator and copy constructor, what they do is what is called a member-wise shallow copy of the object. So that basically that means for any value that the object is containing, when you make a copy of this, it's basically take every value of every member and then copying these member values into the copied object. Now that becomes problematic if the values are actually pointers, as we will see later. So if you define your own, explicitly define your own assignment operator and copy constructor, then you have to explicitly make the call to the assignment operators of the base classes as well as the copy constructor of the base classes. So here's a kind of generic example here. So let's say you have a class named derived that inherits from a base class named base. This derived class has two members, member one and member two. Here's how you would define or declare the copy constructor of this class. And here's how you would define the copy constructor of this class. So it receives an object of this kind. Then you have in the initialization list of this constructor, it basically calls the copy constructor of the superkind or the base class. So you see that's how the copy constructor of your derived class is calling the copy constructor of the base class. If there would be more than one base class, then you would have a comma separated list calling the constructors of each of the base classes. And then what it does is basically copies the values of all the members of this type of this class into the copied, the newly generated, the newly created object. So it's taking the values of the parameter here, of the members of the parameter, and copying it into the new object that you are creating. And it does that for all the members of this class. So that's what I was referring to before, that you should refrain, if possible, to have this copy constructor here actually making a copy of the values of the base class. You should let the base class copy constructor do that for you when you actually are calling it here. And if all the copy constructors are all organized in this way, it becomes very clear, you know, what copy constructor should be copying what, okay? So this is how the copy constructor is calling its superclass or base class copy constructor and taking care of the copying of the members of its class. Same thing is very similar for an assignment operator. Here you define the assignment operator for the type derived. It's a member of the class. And then when you define this assignment operator, it's a member of this class here, takes a reference to an object of type derive and returns a reference to the object of type derive. Then here, as you may see here, it does the same. So it basically copies all the values of the members of the parameters of the parameter into the data members of the current object that is the target of the assignment, essentially. And then, in order to take care of the members that are inherited, then this is how you are calling the assignment operator of the base class. So you hear this is calling the assignment operator of the base class and passing this parameter to this assignment operator of the base class. Again, if you would have several inheritance, if you would inherit from more than one class, then you would have here one call for each of the assignment operators of the base classes in essentially in a list here. Okay, so this is how you implement your copy constructor for a base class, as well as your assignment operator for a base class. Sorry, for a derived class. So then you might ask yourself, well, maybe I don't, you might say, oh, I will never use my copy constructor. So I don't have to define my copy constructor, so I can rely on the default one. However, you might, it's very important that you understand that the way that the compiler is generating some code, it's possible that your code, you think that in your code, you're not explicitly ever calling the copy constructor, but the copy constructor is often used in places where you didn't probably mean for a copy constructor to be called. So here's some examples. So here, it's pretty clear here that you're calling the constructor, the one parameter constructor of this class here. Here you're using the default parameterless constructor, and here you're using the assignment operator. So that here's, everything is fine. Everything is according to what you may think. However, here, if you do it like this here, it's basically compressing these two steps into one, then the only thing that's going to be called is the copy constructor. The default, here in this case, the default constructor and the assignment operator are not going to be called. So essentially, this object here is going to be passed to the copy constructor of sense to create the new object, see Nancy. So even though there's an equal here, this will not result in your assignment operator to be called, but rather the copy constructor is going to be called. So all this to say that sometimes you might think that your code is not explicitly using a copy constructor, so you may think you don't have to define it because you never use it, but it is going to be used by the compiler, even though your code does not explicitly use it. Other possible places where copy constructor would be used is when you pass a certain object. For example, you pass an object of type sent to a certain function, copy constructor by value, copy constructor is going to be used to make a copy of this value and then use it internally in the function. So passing by value calls the copy constructor. If you return an object by value, copy constructor is again called. If you create an object and there's a certain conversion chain, as we saw earlier, that is being used to convert an object of a certain type into an object of another type, it's possible that the constructor, a specific constructor is going to be used in this chain, even though you did not put code explicitly that is calling a constructor. All this to say that your copy constructors or copy constructors are likely, very, very likely to be used, even though you don't make explicit use of them in your code. The compiler may decide to call your copy constructor. So that brings the notion of a shallow copy versus a deep copy. So essentially what I was describing here before, you know, when the copy constructor is implemented here, so essentially what I'm doing here is I'm doing a shallow copy of the value that is contained by every member. Okay, so I go over the list of all the members I have, take the value in the source, put them in the target. Okay, so that's essentially what is called a shallow copy, taking value, putting it value of the source, putting it into the value of the target. So that's what your default copy constructor and assignment operators would be doing. The problem becomes when you actually have some data members of your class, which are pointers. Then in this case, if you use member-wise copy or shallow copy, then what's going to happen is that the values that are going to be copied are the pointer values. So that would mean that your object that the new object that you're creating, let's say using your copy constructor, would be a different object. But these two objects, if they contain pointers, these two objects would be pointing to the same values, which is probably not what you want, okay? So that is called, that's what is called a shallow copy. And that's opposed to a deep copy. Deep copy would actually be making a copy of the values pointed to, and then create the object with copies, which contain copies of these pointed values. We'll see an example right away. So let's say we alter a little bit our employee class and salaried employee class. So, and then we make the members as pointers. So now they used to be not pointers, now we make them pointers. So all of these here are pointers, and this one is pointer. Then if we would have, as is the default assignment operator in copy constructors doing, if we would have a shallow copy of, if the assignment operator in the copy constructor would be doing a shallow copy, then what they would do is to take the name of the object to be copied and assign it as the name of the copied object, and then do this for every of the members here. But of course, then what's happening is that I'm only copying the pointer values. So that makes it so that whatever is the name, because if it's a pointer, then the string name actually resides on the heap. And then I have a pointer on this object that is pointing to the string that represents the name of the employee on the heap. If I make here this copy here like this, like so, then I actually make another pointer that points to the same place. Basically, my two objects have this not only the same name, but literally if I change the name of one, I'm going to be changing the name of the other one, because they contain a pointer, one each pointer to the same object of type string, which is their name. That's highly probable that that's not what I wanted to do. So if you would have a shallow copy of this object that contains pointer, that's what it would be, okay? And that's probably not what you want. So that's basically what happens here. So it's in my main function, I create a salaried employee SE1, which has these values here as their data members. Then I create another employee SE2, and then I assign it to, I assign SE1 to it, which, as we saw earlier, would be calling the copy constructor, which would be doing this member-wise shallow copy here, basically copying the pointer values. So essentially, the pointer values in here would be assigned here, making, for example, this name here that used to point here, and this name of the other object here would be pointing also to the same name. So yes, these two objects appear for now to just be copies of one another, but because they're pointing to the same values, if I change the values of one of the two objects, I'd be changing the values of the other also. Again, which is probably not what I want. Solution here is to do a deep copy. So these are basically here the same. If you want to do a deep copy, copy constructor and assignment operator that implements a deep copy, then I need to make a copy of the values that are pointed to by the pointers, and then make the new pointer point to this copy of the value. So in order to do this, of course, I must call new and then take the initial value, essentially calling the copy constructor of the string, which is going to make a new string object on the heap that contains, yes, the same value, but now is really a copy of the same value. And then assign this new pointer to name, and then do the same for all of my objects or my values that are pointers or data members that are pointers in my class. And I'd be doing exactly the same concept for the assignment operator or the copy constructor. So essentially here, what's happening here, I have the same code, except that here you see that SE1 is pointing to these values here. And as I'm creating SE2 here, which is calling my, which is calling my deep copy versions of my assignment operator of my copy constructor, then it would make a real copy or deep copy of this object here by, for example, taking the value of this, the name here, calling new to create a new string, and then making this object point to the copied value. Okay, that's probably what I wanted. But the point is that your default constructors and assignment, the default copy constructor and assignment operator would not be doing this. Okay, that actually the default ones would actually be exactly the ones that I've explicitly written here. Okay, so that would be exactly what the default ones would be doing. It's probably not what you want. So if that's not what you want, then this is here what you want. Okay, so let's go to multiple. So I'm going to reiterate here. Very important, if you have some of your classes that have at least one pointer as a data member, which happens very often, then you must implement your own assignment operator and constructor explicitly by hand. It's actually a very good idea to take the habit of yourself always implementing your own assignment operators and copy constructors. So let's go to the interesting notion of multiple inheritance here. So as I hinted at before, multiple inheritances, well, we all know what is inheritance, but in the notion of multiple inheritance, you can actually inherit from more than one base class. Now, this is a very controversial concept. Some people say that it should never be used. It actually does not ever need absolutely to be used. For any design that you may imagine that uses multiple inheritance, there's a corresponding design that uses only single inheritance. So there's no design that you can imagine that absolutely requires multiple inheritance. Okay. Whatever you can do with multiple inheritance, you can do it with single inheritance. So it's not a necessary feature. It might be more elegant, it might be more flexible, but that is not absolutely necessary. But still, some languages such as C++ provide it. Thing is that it makes the design of the programming language much more intricate. Okay. By extension, makes the use of the language also more tricky. Okay, and that raises the notion as to, well, someone might say, well, I can design a Java class, can inherit from another Java class, and then can extend or use a certain interface, implement a certain interface, or even a set of interfaces. So you might say, well, this is kind of multiple inheritance. Abstractly speaking, yes, this is some kind of multiple inheritance. However, the notion of an interface is different in Java, is different from the notion of a class. There are things that you can do with classes that you cannot do with interfaces. These restrictions would be there to basically avoid, to allow you to inherit from, to implement several interfaces without having to deal with the ambiguity problems of multiple inheritance. Okay, so no, You cannot say that Java has multiple inheritance because it allows you to inherit from one class and possibly several interfaces. Implementing an interface is not the same concept as inheriting from a class. Essentially, an interface is some kind of contract or blueprint that you impose on a certain class. The interface by itself does not provide, for example, code for some of the functions. Well, some implementations do, but keep it simple. Basically, you can say that an interface is some kind of contract that you impose or list of member functions that must be implemented by a certain class. Okay. In C++, you can actually inherit literally from several classes at the same time, which creates some problems, as I will exemplify here. So you can say, for example, I have an instructor which has a list of courses, which is the course load of the instructor. And this instructor has an ID, for example. Then I might say, well, I might have a student, which also has a list of courses, but which are list of registered courses. And then the student has a student ID. Then I might say, well, what about a teaching assistant? A teaching assistant is an instructor that has a course load as well as a student that has a list of registered courses. So if I have multiple inheritance, I'm going to say, well, a teaching assistant is at the same time a student and an instructor. Basically that it would inherit the course load member from instructor as well as the registered course list from the student. And then would have two different IDs, an employee ID and a student ID. Seems very simple. Actually, a very natural way of expressing these relationships. However, it gets hairy when there is some members that are common between the different classes that you inherit from, that you multiply inherit from. What if, for example, I add a name to my class instructor as well as my class student and an address? So basically that would mean here that now my teaching assistant is inheriting a name from an instructor and a name from a student. Essentially that there's two things in my teaching assistant that are named name and two things which are named address, okay? So in C++, yes, you can have that. Yes, it's problematic, but yes, you can have that. The way to use these two different names and addresses is actually to use this scope resolution operator. So for example, if you create a teaching assistant, you can refer to the name, the instructor name of this teaching assistant by going instructor : name. And then there would also be a student : name of the teaching assistant. Of course, here that does not make sense. It's just to provide an example. All this to say that if you inherit two members which have the same name, if you want to refer to them, you have to use the scope resolution operator. If you want to refer to them independently, because they have the same name, but they're defined in a different scope. So that's why that's a good example of using the scope resolution operator for apparently different things that we've saw before, but it's the same concept. You basically refer to name here in the scope of instructor. If you want to refer to name in the scope of student, you would use a student : name. So, so I might say, so I'm gonna essentially factor out the name and address and then create a class person. And I'm gonna say that instructor inherits from person and then student also inherits from person. You might say, oh, that's gonna solve my problem. But no, it's not gonna solve your problem directly. What's gonna happen if you do that in C++, you have the TA inherits from student and instructor, and the instructor inherits from person and the student inherits from person. So what's going to happen if you do that in C++ is that essentially there is going to be a person part of the instructor as well as a person part of the student. So essentially, you're going to end up having the same problem, but scattered over an inheritance hierarchy. Okay. So there is still really two different names and addresses for the same teaching assistant object. Okay. You can still refer to them separately using the scope resolution operator. So you would still here have two names and two addresses for the same teaching assistant. Because there would be for the so the teaching assistant is composed of an instructor and student part, and the instructor is composed of a person part, and the student is also composed of a person part. And these are not, as you express here, these are not, this is not saying that these two person parts are the same as expressed in this program. If you want to do that, then you have to use what is called virtual inheritance. So here, this is the design that we used to have. Okay, so basically there are two person parts to one teaching assistant object. What we probably wanted is to express the fact that instructor and student share a common person part. If you want to do that, you have to use virtual inheritance. I'm going to exemplify that with two different examples. So here what you do is that if you use virtual inheritance, you are expressing the fact that in your network of inheritance, up in the inheritance chain, there is two occurrences of the same class. And then you want to express the fact that even though there are two different paths to two classes with the same name, you want to have only one part that is going to store a common occurrence of an object of this kind as a part of the object that you're trying to create. Okay, that's essentially what virtual inheritance is. It is a way to go from this version of your design to this version of your design. That's the only use of virtual inheritance. So that actually changes the way in which the objects are created. If you remember the order in which the parts are created, if I create a teaching assistant, then it's going to create the person part, then the instructor part, then another person part, then the student part, then the whole teaching assistant. Whereas here, if I create this, an object of this kind here, it's going to create the person part, the instructor part. Then when it comes to the student, the person part has already been created. So it's going to create a student part that uses the same part as instructor. So it does not need to be to basically, you would not result in having here two different person parts for this particular design. So you see that if you when you declare virtual inheritance, it has a influence as to what are the different parts and the order and occurrence of calling of the constructors, as I will show by some examples. So essentially what happens here is, when you have this special case here, if that would be this case here, then you'd be calling a person constructor, instructor constructor, and then person constructor again. Whereas if you have this design here, then the person constructor would be called only once, because there's only one person part in an object of type teaching assistant in this example. So you see that adding virtual inheritance inside of inheritance graph changes somehow the order or occurrence, the calling order of calling of the constructors. Essentially, some constructors, if you compare the order in which the constructors are called with or without virtual inheritance, sometimes when you virtually inherit a class, that results in some of these constructors to be ignored or not being called more than once. So here's an example here. So you have class D inherits from B and C. Class C inherits from A. Class A inherits from A1, and class B also inherits. So both B and C inherit from A. B and C inherit from A. So here, this is my design. I don't have virtual inheritance here. So if I call my constructors here I have both a one parameter constructor and a parameterless constructor. Here, this is to show the difference between what happens if you call the default constructor or if you call another constructor. As we saw before, if you call the non-default constructor, you have then to explicitly make it your own chain of what constructor are going to be called. For example, when I call the constructor of D here, there's no initialization list here. What's going to happen is that it's going to call the default constructor of B and C. However, if I want to create my own chain, for example, if I call this constructor here, and I want the constructor of one parameter constructor of B and C to be called, I have to put these calls explicitly in my initialization list. If I create this constructor here and I don't put anything here, it is going to call the default constructors of the base classes. If I want to call other constructors, I need to put them explicitly in the initialization list. So that's why I put both kinds of constructors in the example. So if I create an object of type D using this constructor here, then it's going to result in, as we saw before, we create a D, it's going to create the B part, which is going to create the A part, which is going to create the A1 part. There's no other inheritance in the chain, so it's going to resolve the constructor A1, then the constructor A, then the constructor B. Then it's going to do the same on the other branch here, and it's going to create the A1 part and the A part, then the C part, and then eventually the D part that is composed of the B and C part. So that's basically going to call A1A, B, A1A, C, D. Okay. So that's what, and you clearly see here that there are two A1 parts and there are two A parts to this object, okay? Or two A1 parts and two A parts of this object. So that's maybe what I want, but maybe not. So what if what I want is actually that there should be only one A1 part in this whole object, that I don't want, for example, to have two different A1s, okay? Essentially, that's the same example as I had here. What if I want to have, to represent the fact that the instructor, that a teaching assistant is both an instructor and a student, but is also a person, and there's only one person, okay? There's no instructor person and student person. That's the same idea here, except in a different graph. Now, what if I want to have only one A1? So then what I would need to do is to add the virtual keyword in the inheritance relationship between A and A1. So in my class A here, I want to say that there should be only one A1. The way to express that is to put virtual here to say that A virtually inherits A1. So that would result in, when I do the traversal here, that I would only go once here at the top, and that only the first occurrence of my tree graph traversal, the first occurrence of A1 would result in creating a new part and calling a constructor for A1. Okay. So eventually what's going to happen here is that if you create an object of type D, then you're going to have A1, A, B, and then A, C, D. Okay. So you're not going to go twice here because you already went there once before. Okay, so that's the effect, the runtime effect of putting virtual here. So essentially here, what you have to do is, okay, so how is this going to happen? So basically what you're expressing here is that when you're creating a D object, there should be only one A1. If you would keep this call to the constructor A1 here, then when you come to A the first time around like this, when you start like this and you go here, then you would call the constructor for A1. Then when you come back from the other path and would come here, you would still be calling the constructor for A1. Okay. So that's what you don't want, for A to actually call to create two different parts, for one for each of the different paths in the graph, basically. So the effect of putting virtual here is that any time that this class would actually call a constructor to A1, it's going to be ignored. So even if you put your constructor here if you put your constructor call here explicitly in this the initialization list, it would not be called if you have virtual here. Okay. What needs to happen is that when you create a D, then you need to actually call the constructor for the unique A1 that you have in this entire graph. So you have to add this explicit call here in the initialization list of D for the A1 constructor to be called, in fact, before you ever traverse this whole graph here. So if you put virtual here, it's going to make it so that any call from A to A1, A calling a constructor of A1 is going to be ignored. Okay, then that makes it so that you need also to add the explicit call at the class that actually inherits both of these parts. Okay. So that's one example. Let's go to another example, a little bit more complicated. So in this case, I have basically two diamonds. So that's what is the diamond problem. The diamond problem is a multiple inheritance problem that makes it so that you potentially have things that are replicated. Okay, you may inherit, eventually you inherit from several things, and eventually down the line there is some of the things you inherit from, they both inherit from the same thing, creating some kind of diamond in your inheritance graph. That's what is the diamond problem of multiple inheritance. So in this case, you actually have two diamonds. So you have E that inherits from C and D, C inherits from A and B inherit from V, and then D also inherit from V. So in this case, you basically have 1, 2, 3 parts V to an object E. If you would have an object of type C, then the object of type C would have two parts V, if you would not have multiple virtual inheritance. So if you're creating an E that actually create the order of the constructors, which is depicted here by the execution trace. If you create an object of type E, it goes like this here, creates a V, or calls a constructor of V, constructor of A, goes back here, constructor of V, constructor of B, constructor of C, goes back here, constructor of V, constructor of D, and then constructor of E. So that's VA, VB, CVDE. So that's the order of constructors that would be called. So you see that you actually have 1, 2, 3 parts V, because this V is inherited 3 times by 3 different classes in this graph. If you create an object of type C, which is depicted here, then you would have VA, VBC. So you see here that in this example, there's 2 embedded diamonds in the inheritance graph. Now, if I want to avoid these, if what I want is to actually have only one part V, then I would need to have the 3 of A, B, and D to virtually inherit from V. So here I would add A virtually inherits from V, B virtually inherits from V, and C and D virtually inherits from V. Now, if I actually do that, then that would mean that any call to the constructor, to the V constructor by A, B, and D would actually be ignored. Even if I put them, they would be ignored. Then that also means if they are all ignored, that means I must add somewhere. If I want to explicitly call my own constructor, I need to put it somewhere else. Where is this somewhere else? For example, if I want to have only one part of V for a object of type C, then that means I must explicitly call my constructor for V in the initialization list of my constructor C. So in constructor C, I need to insert the call to the constructor of V. And I do the same because I have this other diamond here. So if I want for an E to have a common V through A, B, and D, then the A, B, and D, as they are virtually inheriting from V, this will not result in the constructors to be called. So these three here, 1, 2, 3, would actually be ignored. The calls to the constructors of V through A, B, and D would be ignored if I have virtual inheritance. So where is this constructor should be called? At the level of the E. So that's why I have to add my constructor to the V, the common V of an E. I have to call it at the level of the initialization list of my class E. So that's about it for that. So very important, two things. If there's, you don't have to use a multiple inheritance. So that doesn't mean that what I just explained is not important. It's actually very important to understand that some designs you might encounter will use multiple inheritance. And I also believe that by understanding how multiple inheritance is working makes you better understand how regular inheritance is actually working. But one of the basic things that is important to get from this lecture here is the notion of the shallow copy and deep copy. As you understand, in the project, I've somehow forced you to use pointers as data members. So that is indeed forcing you to implement your assignment operator in copy constructor by hand, as I instructed here. So that's it for this video. Thank you.